Bismillahirrahmanirrahim. Assalamu alaikum everyone. I hope you all are good and healthy in this difficult time. So let's start our today's discussion. Today we are going to talk about the 8051 assembly language programming. In the last lecture we got some basic idea about the 8051 microcontroller, and we also discussed about the RAM space allocation of the 8051 microcontroller, which is going to be handy when we will move on towards the explanation of examples. So before moving on towards the programming of assembly language, we have to understand these two little things, the opcode and the operands. What is an opcode? Opcode tells the assembler what operation is needed to be performed, and on the things on which the operation is being performed are called the operands. Here in this instruction of move, the operands are A and B, on which the following operation is performed, the move operation is performed. So it tells the assembler, opcode tells the assembler what operation is needed to be performed on the following operands that are written on the right side. So these are the two important things that we will use in the assembly language programming: opcodes and the operands. Opcodes are basically the operations that are needed to be performed on the following operands. So let's move on towards the core things of assembly language, the elements of assembly language. There are three most important elements of assembly language: assembler directives, instruction set, and the addressing mode. They have their own purpose. So let's move on towards the assembler directives. Assembler directives, what are assembler directives? Assembler directives are the instructions to the assembler about the program, and the most important assembler directives, I have listed a few of them, and there are many, while I have just listed the few most important that are most frequently used in a particular assembly language program. The first one is of ORG, which is also known as the origin, which is the short form of origin. It tells the assembler from which location the program is going to start. For example, if I write in an assembly language program, it tells the assembler that my program in the microcontroller ROM, it is starting from this 00 address, and it will move on to fill the upward addresses. So this origin basically sets the platform on which from which the program is going to start. Then I can also write that the origin can also be 300H. So what this means is that the program, if 300 is here, then the program is going to start from here, and it will move on to cover the other locations in the ROM. So it tells the program it tells the assembler from where or from which location the program is going to start. That's the main use of the origin instruction. Now let's move on towards another directive that is most important, and that is the end instruction. What this tells is, this is just a simple flag for the assembler to stop its process, because the program has ended here in this line. It just tells that program is ended here, you have to stop performing any action. There is no program ahead of this instruction. And if we write anything after the end instruction, the assembler is not going to entertain that instruction, because the assembler have ended its operations here. So that was the end instruction. Now let's move on to these two instructions. DB is basically define byte instruction. It defines the 8-bit data, and for the various types of data, either it can be decimal, hexadecimal, it can be in the form of binary, it can be in the form of a string, in the form of ASCII, and there are various ways in which data can be defined, and I am going to write for your understanding, for example, if the data is in the form of decimal, then it can be written like that: db is equals 28. 28 is a decimal that is defined by the db instruction. Or if the data is in the form of binary, I can write the 8 bits here like that. Or if the data is in the form of hexadecimal, it can be written like that. Or if it's in the form of ASCII code, then I am going to use these inverted commas and my data is in there. If my data is in the form of string, like my name is so that's how we use the define byte instruction. It is used to define 8 bits of data in the assembly language program, and we will see the use of this assembler directive in our program when we will start discussing about the examples. And let's move on towards the another assembler directive, that is EQU or equate instruction. It basically equates a single word that we are going to use again and again in the program. We can use it for our own ease. For example, I am going to use this 25 again and again in my program, and I am using it for my counting purposes. Then I can equate it with another simpler word. For example, C. I can equate it with C. So whenever I am using this 25, wherever I have to use this 25, I have equated it with C. I can easily write, instead of 25, I can write C. For example, I have to move this 25 into another register. For example, it's R3. Then I can simply use this C instruction. It's just so easy for us to remember. So that's the equate instruction. Let's move on towards the addressing modes. So what are basically addressing modes? Addressing modes are the methods, the way with which we are going to access the data from the operands. So addressing modes are the methods through which we can access the data. There are 5 most important addressing modes that are being used in the assembly language programming of 8051, and let's start discussing them one by one. First of all, we are going to start with the immediate addressing mode. Immediate addressing mode means the data is immediately addressed and the data is immediately transferred towards the other location. For example, in the assembly language, whenever we are using immediate addressing mode, we will use hashtag with the number. For example, I am going to move a data into accumulator or A, and it's, for example, 49H. So what will happen is that, for example, this is A, it's an address, the data is directly 49H is moved into accumulator. Here the data is directly accessed and moved in another location. So you can understand how I have accessed this data using the immediate addressing mode. And the way to understand the immediate addressing mode is to see this hashtag. It's the only used for the immediate addressing mode. Now let's move on towards the register addressing mode. In this, we are not directly addressing the data. We are using a register to get our data from it, to get the access of our data from it. So let's discuss the register addressing mode, in which the source and destination both are registers. For example, A and B, they both are registers in which the data is, for example, in B the data is 45, then it is moved into accumulator, and now the accumulator have got 45. So that's the register addressing mode, in which both are registers from which we are accessing the data. Now let's move on towards the direct addressing mode. Indirect addressing mode is a little bit different from the immediate addressing mode, and as we know that in the immediate addressing mode we use hashtag for directly accessing the data, but in the immediate addressing mode we use hashtag, and in the direct addressing mode we use direct addresses to access the data. For example, if I want the data to be moved, for example, pardon my writing. So what will happen in this instruction, there are two addresses 00h and 07h, and there is some data that is in the 07h, for example it's 1, then it is moved in to the 00h location which is in the ROM, and it is saved there. So here we are directly addressing the data, but we are taking the access of data from the addresses. Now let's move on towards the most important addressing mode that we are constantly going to use, and it's the most important, and it's the indirect addressing mode. Whenever you will see this at the rate in a program, you will understand that indirect addressing mode is used in this program. So indirect addressing mode, for example, I am going to write this instruction that A move this. So what will happen, this at the rate, first of all you have to know this at the rate is used for only two registers, R0 and R1, and how it is going to perform an action, there is a concept of pointer here. This at the rate is basically pointing towards the data, and the data is, for example, in the R0 there is a number which is pointing towards the data which is at this address, and it's, for example, it's 01. Then what is going to happen is that first of all the assembler is going to move towards the R0. Here it will see that the 33 is there, and 33 is basically an address that is pointing towards the data, and the data is 01. It will take it from there and it will move it in the accumulator. So the data is accessed, but it is indirectly accessed. That's why we say that it is called an indirect addressing mode. And then there is another index addressing mode. There is another addressing mode which is known as base index addressing mode, and we use it for the addressing of data from the RAM or from the ROM, read-only memory, or from the external data. And here the data is being used or accessed with the concept of pointer, but there is another register being used here, and that register is known as DPTR. It's a 16-bit register that is used in the base index addressing mode, and the instruction looks like this: move C and move X, and C here denotes that the data is present in the code or in the ROM, and here X denotes that the data is in external memory and it is going to be accessed, and it is written like that. Here the data is being accessed through the DPTR register, and in this instruction, in the upper instruction, the data is in the ROM, and in the lower instruction the data is in the external memory from which it is being accessed. So that was all about our today's lecture. So thank you very much for sticking towards the end, and take care of yourself. Allah Hafiz.